folks do not like using the MDA tables. Reason for that is that in the past, people just turn on all the MDA tables, open up all the floodgates, and they would identify that this causes some system slowdowns. Well, you don't have to run all of the MDA tables. You don't have to enable all the pipes. You don't have to enable everything. There's just a few that really matter from a performance standpoint. Vendors will tell you 1, 2, 3% overhead of one CPU for monitoring. I honestly have not been able to measure that much, and most of these tools will also measure the cost of running the queries that they're using to monitor the server. So you can actually monitor that yourself and validate this as you're going in to look. So lightweight monitoring, agentless architecture, this becomes very important as well, because if you have to deploy agents to your boxes, it's much harder to get permission to put an agent over there on the box that you're running ASE on than it is to simply connect up something that once a minute checks to see what's in the MDA tables and brings the information back. So the intelligence takes advantage of the content of the MDA tables, accumulates these delays, these wait times that are accumulated as the server processes queries. Now, as we look at these and we start digging down into them, we find that we want to draw a variety of correlations, and we'll talk about that in a little bit. So we can do this to identify the most important problem queries. Note that the problem query is not always the obvious problem query. Sometimes you get lucky, and the problem query is along the lines of, well, gee, something which is running for 3 hours and sucking up 80% of the resources. Those are usually kind of easy to find and kind of easy to fix. Either tell people don't run that or fix the query. The ones that are a little bit harder to find are the ones that run, 10,000 times a minute and take, 800 milliseconds. Well, nobody's going to call and complain that something is taking 800 milliseconds. It's sub-second. They're going to ignore the fact that it's running. But if it's running every 10,000 times a minute, what's happening? It may be that that query is sucking up 30, 40, 50% of the resources on your box. I'm not making those numbers up. I've seen those numbers. And if that's happening, tuning that 800 millisecond query down to 20 milliseconds makes a lot of difference. Now, that's not always the problem. It may not be a particular query. It may be a set of queries. It may be a set of queries going after a set of tables. You may have identified that there's some locking going on. The idea here is that we want to do is expose the critical resource. What is it that's causing the bottleneck? Identify it and fix the actual problem. A lot of folks have this knee-jerk reaction. They throw resources at a problem, physical resources, throw memory, throw a disk, throw a CPU. And that knee-jerk reaction is honestly because sometimes it's cheaper to throw hardware at a problem than it is to throw people at a problem. The catch is when you do that, it tends to snowball and get worse when it hits you the next time. So when we do this, DBAs tend to be able to manage more servers. Migrations become quicker. We're using this tool right now to help shorten a development cycle from a 12.5 to 15 upgrade that we're performing at one of our customer sites. So, analysis techniques. The idea here, DBAs are frequently in a tough situation. They're responsible for performance even though they're usually not invited in until the very last second. If you're really lucky, the DBAs have an in with the development group. I know that when I'm running DBA groups, if I'm not doing it myself, I will delegate somebody to be part of the development meetings. And that lets us know when things are likely to change, when the changes are going in. We get to prep for them. On a really good day, we'll get to do code reviews, identify what's going out there, participate in the application architecture, at least from a database perspective. On a bad day, you find out on Monday morning that the changes went in over the weekend, and all of a sudden it's slow, and when you say, what changed, they said, well, didn't you get the memo? We had a fix go in. What you need to do is get the visibility into what's hitting the database, because sometimes you can look at it and say it's not a database problem. Look, we're getting this throughput. Nobody seems slow. Average response time is whatever. The response time issues must be someplace else. But it's nice to be able to actually have facts to back that up, and that's one of the things that we're going to pick up. So, key components of the things that we're going to discuss behind the performance intelligence. First, we're going to measure the amount of time that's spent. It's not so important how many operations we've got, although it will matter that we're doing something once versus 1,000 or 10,000 or 100,000 times. What we really want to do is find out how much time are we spending waiting for the mass operations? How much time are we spending waiting for buffers? How much time are we spending waiting for the networks? Because sometimes you can make knee-jerk decisions about query resolution or speeding things up. If, for example, 80% of your wait time is network wait, well, guess what? It's really easy to say, okay, let's quickly double the network packet size and see if that goes down, see if information is coming across a little faster. Sometimes, though, you may look at the queries that are performing these activities, because if you know all the wait time is associated with only 2 or 3 queries, we had this one a couple months ago. It turned out that Brio, which is a reporting tool, was bringing back 800,000 rows of data, selecting the 7 rows that it wanted, and then displaying the 7. Well, guess what? The answer there isn't to speed up your network. The answer there is to fix the query and only bring back the 7 rows that you care about. So you have to be careful about those automated queries that get brought back. So measure the time as opposed to the operations, but don't do that to the exclusion of all else. Do focus on the queries. Look at the queries that are running and what they're doing. Sometimes it turns out that the subset of queries that you're running need an index. This is a relatively common theme that I've seen when I'm doing performance and tuning gigs. You add 1 index and all of a sudden 6 or 7 of the top hitting queries get better as opposed to just 1 or 2. Particularly when you have situations where table locking is occurring and updates are not being performed properly because, hey, no matching index, you get yourself a table lock. Next, we want to capture this information on a continuous basis. What does that mean? That means that we want to know at 3 in the afternoon when somebody calls and says things were slow this morning, what was going on this morning. At this point, we can go and figure it out. If we want, we set alerts on this thing so that if, for example, average response time gets a little bit too high, we act on it so that when people call and say, hey, things have slowed down, you can say, working on it. That really impresses folks. And the historical view, which is the ability to go back and take a look at these things, which is the benefit of the continuous capture. So benefits of doing real warehousing is you pick up trending. You can find out for specific queries if the time that query is taking is starting to go up, down, or not. You can find spikes, these anomalies that get picked up. Gee, it looks like every day at 2:30 in the afternoon, things go a little bit haywire. Let's go take a look at 2:30 in the afternoon, find out what activities are going on at that point, and see what's causing the spike. The relationships between, for example, round-trip client to database and back is going up or down. And then you can do a lot of slice and dice and drill down. So, okay, we're spotting a trend. Once we've spotted the trend, let's find out what queries are involved. Oh, gee, a lot of these queries are having I/O issues. Let's, instead of doing this on a per query basis, let's look at the I/O. Okay, now we've isolated the I/O. Take the top 5 users, top 5 queries, top 5 whatever, and pick this up. That dimensional ability to scan through this and identify what the cause is and fix these things one at a time is one of the critical aspects of what we're trying to do. Now, identifying the wait types themselves, it's relatively new. This came about in mid-12.5. In fact, when I wrote my 12.5 book, Sybase didn't even tell us that this thing was on the horizon, or we would have had a chapter in it. So if you take a look at our, the 12.5 admin book, it doesn't even mention this stuff. So here's what happens. When you're running against ASE, you've got some sort of wait occurring. That wait might be waiting to bring a page back, getting into cache, waiting for a latch to be released, lots of different things that might cause waits. Or you might be processing with the CPU. Now, processing with the CPU isn't really a wait state. It's more of an execution state, but that is something that the end user is waiting on, and this is something which becomes very relevant. So while these things are going on, we're logging the amount of time it occurs, and also on a per query basis, we're picking up the information and saying, okay, this query is spending 3% of its time with CPU, 5% of its time with disk, and oh gee, 93% of its time with network I/O. So some common wait types include things like latch weights. Latch weights are kind of insidious. A latch is a special case of lock. It's a non-transactional lock which controls access to things like cache, I/O buffers, stops different processors from stepping on each